Next, under the variable separable format, we have method of substitution. So to separate the variables, we can use substitution method. Let's see how. So the first question, in order to understand the substitution, under root of y minus x. So here you can see that y and x cannot be separated since they are a function of square root. So here in this case, to convert it into variable separable format, we'll make use of the substitution. We'll use the substitution. A simple substitution will take y minus x equal to, let's say, t square. So dy by dx minus 1 is equals to 2t dt. Let's substitute over here. So dy by dx can be written as 2t dt plus 1 and square root of t square dt by dx. So this thing would be 2t dt by dx is equals to t minus 1, right? And dt 2t by t minus 1 is equals to dx. Now integrating it in both the sides. To integrate this thing, we'll do some rearrangement, add 1 and subtract 1. 2 is taken common, and the integration of other side is simple. We'll add some constant c. So this will get converted into t minus 1 plus 1 upon t minus 1 dt is equals to x plus c. Integration of 1 will be t plus integration of 1 upon x will be ln t minus 1. Substitute the original values. Square root of y minus x, 2 will be multiplied over here also, 2 ln square root of y minus x minus 1 is equals to x plus c. So this is the solution to the given differential equation using the method of substitution. Then another question for the substitution we have is dy by dx is equals to x plus y plus 1 upon x plus y minus 1. Here also, if you analyze, right, again separating x and y is not possible. So we'll use the method of substitution. X plus y equal to t. Differentiation of x will be 1 dy by dx is equals to dt by dx. Here the t is a implicit term. So dy by dx will be dt by dx minus 1 x plus y t plus 1 upon t minus 1 dt by dx t plus 1 t minus 1, and this 1 gets shifted on the other side. It will become 2t by t minus 1, right? Here once again we can do the rearrangement, dt by 2t into t minus 1 and dx, integrating in both the sides. Simplifying this, t upon 2 I will take common, t minus 1 upon t dt. The integration of dx will be x. So half integration of 1 minus 1 upon t dt is equals to x. Will add some constant c. So half integration of 1 is t, 1 upon t is ln t equal to x plus c. Half, taking out half common, the value of t was x plus y minus ln x plus y is equals to x plus c. So this is the solution of the given differential equation using the substitution form. Let's take one more example. Dy by dx plus 1 is equals to e to the power x minus y. So here once again separation of the values into x and y won't be possible. If you want, you can try it, but for sure the separation that is taking all the x terms on the one side, taking all the y terms on the other side is not possible. So once again we'll use the method of substitution, and substitution will use will be t. So let's try. Dy by dx will be replaced by 1 minus dt by dx plus 1 is equals to e to the power t. So dt by dx, 1 plus 1 is 2, and 2 minus e to the power t, dt by 2 minus e to the power t is equals to dx, integrating it on both the sides. To solve this integration, we'll need to use one more substitution. Let's take it as z. Differentiation of integration or differentiation of 2 will be 0, e to the power t dt by dz, and d differentiation dt and differentiation of z will be dz. So dt can be replaced as dz by minus e to the power t into z, and dt to dz, and let's take some steps. Dt can be replaced by dz by e to the power t minus e to the power t, and bracket 2 minus e to the power t we have taken as z. So z. Integration of the other side will be x plus c. Here e to the power t, it can be written as z minus 2. So z minus 2 into z dz is equals to x plus c. This can be used this can be solved using method of partial fractions. So we'll use partial fraction. B by z is equals to z minus 2 into z. Converting this into partial fraction format, this would be 1. So z into a plus b into z minus 2, 1 upon z into z minus 2 we have converted into partial fractions. Z minus 2 z gets cancelled from both the sides. So here let's find out the values of a and b. To find out the values of a and b, let's take z equal to 0. Then it will give minus 2b equal to 1. So the value of b is minus 1 by 2. And if we take z equal to 2, then it will be 2a equal to 1. So value of a will be equal to 1 by 2. Substitute it. So integration would be a upon z minus 2. So 1 upon 2 into z minus 2 plus b upon z. So value of the b we have minus 1 upon 2 into z, right, equal to x plus c. So integrate it. So 1 upon x format. So it will be half ln z minus 2, and here it would be minus half ln z. It's in the separation format, so we can divide half common ln z minus 2 divided by z x plus c. Half ln 1 minus 2 upon z. Let's substitute. The z is nothing but 2 minus e to the power t. 2 minus e to the power t, and t also we have substituted as x minus y. So further resubstitution. Now just rearrange it and we'll get our answer. Ln 2 minus e to the power x minus y minus 2 upon x minus y. 2 gets cancelled. Half ln, taking out minus common from the numerator and denominator. So x plus c. Here we have the answer. Here you can see the concept of integration also get used up in very detail. Then in the substitution we have one more sum, that is x dx plus y dy plus x dy minus y dx upon x square plus y square is equals to 0. And here they have also given that find out the value when x is equals to 1 and y equal to 1. So at this, with these values we will be able to find out the value of constant. So let us try to solve this differential equation. It's once again cannot be separated into variables easily. The integration of this term is simple, x square by 2. Integration of this term is also simple, y square by 2. But here we have some complexities. So let's try to take out x square common from numerator and denominator. So we'll have as x dy minus y dx whole divided by x square, and denominator will have we have taken out divided numerator and denominator by x square, right? So this is the term now. So here this part, if you inspect, it is nothing but this part. It is a differentiation of dy by dx of y by x. So let's substitute this over here. So the equation becomes plus d by dx of y by x upon 1 plus y by x whole square. Now further we can substitute that, let y by x be equal to z. So x dx plus y dy, this just a substitution of y by x, nothing to differentiate. So dz by dx upon 1 plus 1 plus z square equal to 0. No, this term is a differentiation, just a differentiation of y by x. We don't have to put the differentiation x. So now it's possible to integrate. Integration of x is x square by 2 y square by 2 plus tan inverse of 1 upon a square tan inverse of z by 1 equal to 0. And let's put some constant c. No issues if we put the c over here or on the other side. We have been given this condition, so we can evaluate it. So further substituting the value of z, it's the value of the z is y by x, right? Now we have been given that x is equals to 1 and y equal to 1. So let us put these values and we'll get the value of constant. So 1 by 2 plus 1 by 2 plus tan inverse of 1 equal to c. Tan inverse of 1 is pi by 4. So 1 plus pi by 4 is equals to c. Yes. So the value of constant we have got. We can substitute the value of constant in the equation. Y square by 2 plus tan inverse of y by x equal to 1 plus pi by 4. So this is the solution of the given differential equation. Then next let us take a word problem. It is given that the marginal cost of manufacturing a certain article is given by c dash of x is, that is c dash of s, it represents dc by dx, which is given as 3 plus 0.25x. So this is some equation which describes the cost of manufacturing some article, and they have told us to find out the cost function cx. Cost function, that is c of x, will have to calculate, and they have given that c of 0 is 60. So some word problem, cost function in the differential format we have, and from this differential format we are required to calculate the cost function, and some more additional value has been given to evaluate the constant. So let us start a simple variable separable type of equation we have. So integration will be c. C dash represents the differentiation. Integration of dc will be c. Here integration will be 3x plus 0.25 x square by 2. right? And this is the function in terms of x, 3x plus 0.25 by 2 x square. C of 0 we have been given. C of 0 we have been given as 60, right? So let us substitute. 60 will be equal to 0. Here some constant will be added up. So 0 minus 0 plus k. So value of that constant is 60. Let us substitute this in the original equation. So we'll have this exact cost function x square by 2 plus 60. So this is a cost function obtained from the differential cost function. One more, we have similar type of the word problem related to the maths, that is, this question was related to the commercial applications. A curve passes through the point 5 comma 3 and at any point x comma y on it, product of the slope and the ordinate. So slope into ordinate is y-axis, is equal to the epsica, and epsica is x-axis. Find the equation of the curve and identify. So equation we are required to find out, and equation represents which geometrical figure, either square, parabola, or maybe ellipse. We are required to find that. So slope, it is given by dy by dx. Ordinate, it means the y coordinate, and epsica is x coordinate. A simple differential equation we have. Let's solve it by integration. So y square by 2 plus x square equal to x square by 2 plus some constant c. To evaluate the constant c, we have been given this, that it passes through 5 comma 3. So substitute the values. So 3 square is 9 and 5 square is 25 by 2 plus c. The value of c will be 9 by 2 minus 25 by 2. 9 minus 25 minus 16 by 2. So value of c we have got as minus a. Substitute it. So y square by 2 minus x square by 2 is equals to minus 8. Right? You can take out minus common. So x square by 2 minus y square by 2 is equals to 8. X square minus y square is equals to 16. So this is the equation, right? This is the equation of the curve, and it represents the hyperbola.